I'm Anil Kumar. Welcome to my series on combinatorics. We'll begin with combinations and understand what does NCR or N choose R really means and how it can help us in counting the number of choices in so many different conditions. So we'll see first what does NCR mean? Why is it really called N choose R? We'll look into the concepts of subsets and how are they related with choices. We'll also see how to find the coefficient of polynomials. Well, earlier, while working with Pascal's triangles and binomial theorems, we had few examples to find coefficients of binomial expansions. Now we'll extend it to polynomials of n degree. With the help of the concept of combinations, we can easily find them. We'll now see many examples related to selecting committees or teams with different conditions. So we'll have combinations with restrictions. We'll also understand what does it mean when we say the term at least, right? Or we say both or neither, right? So these terms are very confusing at times, but the examples which I have selected here will help you clearly understand their meanings. Well, the chapter on combinations is never complete without a game of cards. So we are going to end up with combinations in playing cards. I hope you find this interesting and useful. You can always send me an email on the given address or contact me on the website Global Math Institute to learn more from me. Now let's begin with the concept of understanding why NCR is called N choose R. Right? That's very critical. We had been saying it all along, N choose R or N choose K as I've written here in this particular case. So let's try to understand this particular concept. So what I've done here is that I've taken a very familiar example and then we'll actually elaborate on that. So we'll begin with, let us consider P, Q, and R as three prime factors of a number n. How many factors will n have? So that's a very interesting question asked many times in test papers. Well, to understand the whole concept, we'll just check with a simple number which is 30. Now, as you know, 30 prime factorization we can do here. 30 can be written as 6 times 5 and 6 is 2 times 3, right? So the prime factorization of 30 includes only three prime numbers, 2, 3, and 5. So it's a very similar question as we are talking about, right? Now, we need to find all factors of 30. What it really means is the factors are like 1 times 30, right? Gives you 30. 2 times 15 gives you 30, correct? 3 times 10 gives you 30. And then you have 5 times 6, that gives you 30, right? So these are 8 factors of 30, correct? So in all, we have 8 factors of 30 provided we begin with these three prime factors. How do we get to know that there are 8 factors of 30? Well, that is the real question. So let's try to understand this situation. So let's write down the factors as such. We can say that the total number of factors of 30 are, as we have listed, the number 1 alone, and 2, 3, and 5 are the prime factors. So it could be either 2, 3, or 5. So taking one at a time, do you see that? Or we could multiply them. 2 times 3 is 6 for us, 2 times 5 is 10 for us, and 3 times 5 is 15. And when we multiply all three of them, then we get 30. Do you see that? So, in a way, we could easily count the total number of factors knowing that there are three prime factors. You get the idea, correct? Perfect. So we can conclude that 30 has 8 factors, and these factors are, as listed here, 1, 2, 3, 5, 6, 10, 15, and 30. Now let's analyze it further. The factors correspond to the subset of S. Now, this is a technical statement. We are saying actually we are working with these numbers 2, 3, and 5. And how these numbers, as you can see, only 2, 3, and 5 occur at each stage, correct? How is it subset of the set with the elements 2, 3, and 5? Okay, 1 represents not choosing any of the prime numbers. Do you see? Not choosing any of the prime numbers means 1. And in our combination, there are 3 elements 2, 3, and 5. If we don't choose any, then we get 3C 0. And 3C 0 is equal to 1. So we got one of them. Do you see that? Now, the second group of 2, 3, and 5, you see, it is selecting only one of them. That is a singleton subset, right? So 2, 3, 5 represent the subset of choosing only one of them. That means 3C1. 3C1 is 3. The value of 3C1 is 3. Perfect, right? Okay, so these are the three factors if we choose only one of them. Now, if you select two of them, then it becomes 2 times 3, 2 times 5, and 3 times 5, which is 15. So we get 6, 10, and 15, right? So they represent what? They represent doubleton subsets. That means 3C2, right? So 3C2 is again 3, correct? So we get those 3 again. Now the last one here is selecting all of them together. 2 times 3 times 5 gives you 30, and in our combination n choose k, we get 3 choose 3, which is 1. So you see these numbers matching 1, right? 3, 3, and this one is also 1. So not choosing any one of them gives you the very first factor, which is 1. Selecting only one of them gives you the other factors 2, 3, and 5. And we saw earlier, selecting 2 gives you 15, 10, and 6. And selecting all of them gives you 30. So I hope you got the link. So it is kind of making choices. So in all the cases, we found that the number of factors could be worked out from the three numbers which you're talking about. And the answers were, you could also write this as 3 choose 0, right? Plus 3 choose 1 plus 3 choose 2, correct? Plus 3 choose all 3 of them. And that gives you the answer, which is equal to, there are 8 factors in all for the number 30. You get the idea, right? Now, we'll actually get to our real question, and let's see how to interpret that. So now again, why n choose k is called n choose k? Let us again consider this PQR, now a general case, as 3 prime factors of the number n. Now the question is, how many factors will n have? That is the question, right? You know the answer, as we took up an example very similar to this. But now let's try to understand the logic once again. Now what we are given? We are given here that P, Q, and R are 3 prime factors of a number n. And we need to find the total number of factors of n. Well, we have a choice to choose combination of these prime factors, correct? Since you know that the product of factors are also factors, so let's consider the following product. So here we're trying to convert that into a polynomial form. So we have deviated a bit. So we are trying to write this as a polynomial, right? And then we'll relate to its coefficients. So that is the concept we are working on, and see how. So we wrote that the product capital P is equal to 1 plus P times 1 plus Q times 1 plus R. When you expand using distributive property, you get what? You get 1 plus P plus Q plus R plus P times Q, Q times R, and P times R, and then product of all the three, which is PQR. correct? So that is the kind of polynomial you get. Now the terms in this expression corresponds to the subsets of S of PQR. Do you see that? So this is singleton, right? When you don't empty set, when you don't choose any, and this is singleton, these are double, and this is all three, correct? So you can see now once again that the terms in the expression corresponds to the subsets of P, Q, and R. Now 1 represents not choosing any of the prime numbers. Do you see that? That is what 1 is. And PQR represents subsets of choosing only one. That is singleton subset, correct? So these three are your singleton subsets. And the product PQ, QR, and RP represents doubleton subsets. Clear? And the last set here is the product of all three when you select all the three, the set itself, right? So that is how we get three parts of it. Now, let us have a separate look on this forming a polynomial once again. Okay, so let's have a different look, and that is now let us replace PQR with X. So what we did here is we wrote P equals to Q equals to R equals to X, right? So we replaced all of them with X, saying these are prime factors, where X is a prime factor, okay? So in that case, now the product equation becomes P equals to 1 plus X plus X plus X plus X squared plus X squared plus X squared plus X cubed, which basically is the expansion of 1 plus x whole cube, which you know is 1 plus 3x squared plus x cubed. And now you can correlate very easily the coefficients of this polynomial with the definition of NCK. You get the idea, right? So now we observe that 1 is, we observe that 3ck for k equals to 0, 1, 2, and 3 is the number of ways of choosing the subset of k elements from a set of 3 elements. Do you see that? So if I put k as 0, 1, 2, and 3, I get nc0 and choose 0 and choose 1 and choose 2 and choose 3. And these corresponds to the coefficients of the polynomial where we are expanding the binomial 1 plus x whole cube. You get the idea, right? So this can be generalized as NCK for choosing k elements from a set of n. Do you see that? So what we did here is we defined it. So we are now saying is that NCK basically is choose. So it is to choose k elements from a set of n elements. And that's what it means. Do you see that? So each number here, 1, 3, 3, and 1 represent choosing from 3, nothing, or 1, or 2, or 3. You get the idea, right? Now, well, you have understood what NCK really means and why do we call it N choose K, right? Now let's take up an example to understand it even further. Example 1. It's a combination case without any restriction, straightforward, and we would write all combinations of 3-player teams chosen from players A, B, C, D, and E. So we'll just form 3-player teams. So every team will have 3 players, and we're going to select these players from these 5 players A, B, C, D, and E. So a systematic way of writing will be, we can select A and then the other 2, right? So I've made here a list. So let's start with selecting A first and then following a pattern to write the choices. So when we write it, we get ABC, ABD, ABE, ACD, ACE. So with A's, we get all this plus ADE. Now we can begin with B and then BCD and BCE, and then BDE and CDE. So in all, we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 teams where there are 3 players each, right? From 5. But we could have done it faster also. See here. What are we supposed to do? We want to find a combination of 3-player teams chosen from these 5 players. So these are 5 in all, right? So the answer straight away is you have to choose from 5 3 players. Do you see that? So that is what the answer is. So I've written it another form. 5 choose 3, right? Which means 5 times 4 times 3 divided by 1 times 2 times 3. So number 10. So straight away, whenever you want to make choices of teams or groups where order is not critical, we can get straight answer. Do you see that? Now you note one thing here, which is written explicitly here. That is, 5 choose 3 is the correct answer, right? You know that. A, B, C, A, C, B, and B, A, C. Writing A, B, C in different ways will be considered as one team only, right? So in this particular case, you know, we have not added the cases like we have only written A, B, C, not A, C, B, and B, A, C, since they are the same teams, right? So that is important to understand. Order of selecting the team is not important, right? If you think A is the first person selected, B is the second, C is the third, well, in the team, we have only these 3 members. So it doesn't really matter in which sequence do you select. So it is important to note here, and that is order is not critical. Rather, it is not important at all, right? It can be ignored. So whether A is selected first, B is selected first, or C, it doesn't really matter. In this team, if A, B, C is there, they are the same team. Correct? Now, based on this, here is a practice question for you. Selection with a restriction this time. How many different teams of 5 players can be selected from a squad of 8 if the captain must be included? So what we have done is given a slight twist to this question. Now still we have to select a team of 5 players, and we have a squad of 8 in which there is one captain, right, and 7 other players. But when you select team, you have to select the captain. So one person is fixed. And tell me, how will you solve this particular question? Okay, write down your answer and then you can check with my solution. So let's take up this solution now. Example 2, right? Now in example 2, what we've done is, let's read the statement once again. How many different teams of 5 players can be selected from a squad of 8 if captain must be included? So basically, if you look at it, what we have here is 1 plus 7, right? And we need to select 5. So 1 is captain. You have to select captain. So there is no choice, right? You have to select the captain. So 1 out of 1. So you could write this as 1 out of 1. You selected the captain. Now, out of 7, you have to select how many? 4, because 1 has been selected. So from 7, you have to select 4, and that is the answer. How simple is this? Do you see that? We have a condition. We applied the condition first and then selected the rest. That is the strategy. Perfect. So that is what we get here. You can go through the solution. It says, out of the 8 players, there is 1 captain and 7 other players. The restriction is that the captain must be included. So we need to select the captain, and then from the remaining 7, we need to choose other 4 players to form different teams. So there are 1 choose 1 times 7 choose 4, which is equal to 1 times 7 choose 4 is 7, 6, 5, 4. Multiply them, divide by 1 times 2 times 3 times 4. That gives you 35. So there are 35 possible combinations of 5-player teams in this situation. Clear? Okay, let's consider another example, and we'll go back to the coefficients, the binomial coefficients, and then come back with our combination rule. Okay, the question here is, find the binomial coefficient for x cubed y to the power of 6 in x plus y to the power of 9 using the concept of combination. Okay, you know the answer as such. You did it in Pascal's triangle and in binomial theorem. So let's revise that. So binomial theorem, what did you do? The answer should be n. N is 9, right? Choose. I can write better. There are a couple of ways to write this. So let's write 9. And from there we have to choose 6, and that is the coefficient, right? 9 choose 6 is the answer. So from binomial theorem, you know, it is 9 choose 6, which is the answer. Now let us see, how do we correlate with the concept of combination? Okay, so it will be very important to solve complicated equations. That's the whole idea. Okay, now from the knowledge of binomial theorem, we know that the coefficients of the term 3 to the power of x to the power of 3, y to the power of 6 in x plus y to the power of 9 is 9c6, correct? 9 choose 6. Now, let us interpret it from the concept of combination. That is the real question, right? Now, look at it. Now, from the product of 9 factors, this really means what? This means x plus y times x plus y times x plus y. There are 9 factors. Do you see that? So remember, from the product of 9 factors, we need how many x's? 3 x's and 6 y's. We need 3 x's and 6 y's. Correct? So this selection can be done in different ways as explained below. So we'll actually have 2 ways to do it, right? So let's say way 1, and then this is the second way of doing it, right? So this is the first and this is the second. So in the first case, choose 3 x's from a set of 9. So first thing, choose 3 x's from a set of 9. So that gives you 9c3. And then 6 y's from the remaining 6. You get the idea. So first what we did was we selected the x's. So there are 9 factors. So from the 9 we selected 3 x's. And then how many remain? 6 remains, right? So out of 6 we selected 6 y's, and that is our answer. So this gives us the answer. You know both are equal, right? Okay, that could be first approach. Second approach is, why not start with y? Right? You could. Okay. So in that case, we could select what? 6 y's first. So from 9, select 6 y's. And then remaining 3 will be selected from the remaining 3. So that is also the same thing, correct? So either one of them is the correct answer. Is that clear to you? All are equal. So now let us see what the answer is. Well, whether you write 9c6 or 963, you get the same answer of 84, as you can see here. So see the calculations. When we do 9c3 times 6c6, 66 is 1. So 9c3 is 84, that you get, and 9c6 is also 84, right? So we get the same answer. However, I've also shown you here another technique. 9c3, as you can see, can be written as 987 over 123. Now, what we have done here is both numerator and denominator are multiplied by this term 6 times 5 times 4 times 3 times 2. In that case, the numerator can be written as what? 9 factorial. Do you see that? 9 times 8, 7, 6, 5, 4, 3, 2, 1. 9 factorial. And here we get 3 factorial and 6 factorial. Do you see that? So now we could write this answer as in terms of their index, right? So in terms of index, we are getting the answer. So the answer here is 9 factorial divided by 3 and 6 factorials. You get the idea. So if you have a binomial and you need to find the coefficients, you could do it like this very easily. You also learned here that nck is same as n choose n minus k, since you saw that the value of 9c6 is same as 9c3, correct? Both are same. So you know that is perfect. Now this also can be explained with the concept of making choices, right? Let me just say how. So I'll just explain this part here very clearly. You can see that what does nck mean now? It signifies choosing k elements from a group of n. That's what it means, right? Selecting k elements is the same as not selecting n minus k elements from the group, right? So if you have to select n or k elements from n, you may select the others, that is, not select these k, but the other n minus k. Even then you form a similar team. Do you get the idea? So that is the whole concept. So choosing ways of not selecting n minus k elements from the group of n is n choose n minus k. So therefore both are equal. Is that clear to you? Now, one more concept which I was telling you, we wrote in this particular form that makes things very simple for us. If I have a complicated case, let us say, now the question is the coefficients of x to the power of a, y to the power of b, z to the power of c, and so on, r to the power of d, in the expansion x plus y plus z plus so on till r to the power of n is what? So the answer here is n factorial over a factorial times b factorial times c, all the indexes. Do you see that? We get the answer. Important thing here, however, is that the sum of all those indexes should be n, right? That is the condition in binomial theorem. You saw that all the indexes add up to n, right? The degree of the polynomial. Perfect. Now, based on this, here is a question for you. So, I'd like you to read the question, answer, and then check with my solution. Okay? The question is, find the trinomial coefficient of x cubed y to the power of 5 times z in x plus y plus z to the power of 9. You get the idea? So this is a trinomial. This is much difficult question than what you had been doing as a binomial. Now find the coefficient for this term. So from the method which you've learned, you can easily write down the answer, right? N factorial is 9 factorial in this case, divided by 3, 5, and 1 factorial. Do you see that? That should be your answer. So it's so simple once we understand the concept. You get the idea. And you can choose the way. You could select first these, right? You could write select 3x's from 9 of these factors. Do you get the idea, right? First select 3 from this. So you could write from 9 choose 3, right? Now, once you've done that, then you have to select those 5 from remaining 6, correct? And once you've done that, then from remaining 1 you select 1. Even then you get your answer, which is same as 9 factorial divided by 3 factorial times 5 factorial times 1 factorial. Perfect. So either way, you get your solution. And that's what I did. So if you go through this reasoning, do you see this? 9 choose 3 times 5, 6 choose 5 times 1 choose 1 is 84 times 6 times 1, 504. You could make a choice selecting z first or y first. It doesn't matter. It will be the same order, and at the end, it boils down to 9 factorial divided by 3 factorial times 5 factorial times 1 factorial. So we can generalize this particular formula that if you want to find coefficients for a polynomial of degree n, whether the terms could be many more, not just a binomial, in that case, you could easily find it by using this formula, which clearly is n factorial divided by, you have all those indexes, a factorial times b factorial times c factorial till r factorial. But remember, a plus b plus c plus r should be equal to n. That is a condition, right? As all the indexes add up to the degree of the polynomial when you are expanding. Only then we are talking about the coefficients, correct? So that is how such questions can be done very easily with the concept of combination. I hope that is absolutely clear. Now let's take other type of questions which are, well, here's another practice question for you on the same basis. Now it's a tricky one. It says find the coefficient of x square y cube z to the power of 9 times w in, note a change in your polynomial. It is not x plus y plus z plus w, right? What we have is 2x minus y plus z plus w to the power of 15. Do you get the idea? Now, I would like you to pause and write down the coefficient for this particular question, right? So answer this question. So how will you normally do it? Well, you say there's 15 degree. So 15 factorial divided by 2, 3, 2 factorial, 3 factorial, 9 factorial, right? You may write down this answer. However, that be incorrect. Mainly because the coefficient of x here is 2. That 2 is going to add up. And we are using x square. That means we have a factor which is 2 square also as a part of coefficient. And for y, we have negative and y degree is 3. So we also have minus 1 to the power of 3 multiplied to it. So you have to look into the function clearly and then write down the answer. But basics, yes, you could use your formula which we just learned and write down. But you should see exactly how the statement has changed. Incorporate those changes to write down your answer. You'll always get the right one. And here, if I do what I've shown here, right, which is the correct answer as shown here, you will get definitely see a negative value, right? Because minus 1 to the power of 3 gives you this negative value. So that will be your answer for this question. Perfect. So do this question and then check your solution. Okay. So that was kind of a examination question based on what we just learned on coefficients of binomials extended to polynomials, correct? Okay. Now let's talk about the committees and whenever we are making those combinations. So in combinatorics, we actually find the number of committees, number of teams formed, and so many other things. These are very common questions. Question number 6 is a committee of 4 is chosen from 7 women and 6 men. How many different committees can be chosen if there must be at least one of each sex in the committee? So at least one woman, at least one man should be there in each committee formed. That is the condition. So this is conditional combination, correct? Let's see how do we do it. Okay. Now, I will actually discuss two different strategies to answer these questions. The first strategy is when we talk about at least one, that means we could have a combination with one woman and 3 men. That could be one, right? Then we could have 2 women and 2 men. Perfect. We again get a committee of 4. We could have 3 women and 1 man. So we get 4, but we cannot have all 4 women. That is condition, right? Or nor can we have all 4 men. Perfect. So these are the 3 different cases. So here the critical points are 2, which you have to note is the first group is 1 woman and 3 men. So 1 woman is selected from 7. So it is 7C1. Do you see here? 7 choose 1. Perfect. Times. Now there are 6 men. From 6 men you are selecting 3. So 6 choose 3. Got the idea? Since it is and, it gets multiplied. Now the other one is or. Or means add. The second condition, which for you is we are having 2 men and 3 women, right? So 2 men are being selected. Oh, sorry, it is not this group. Sorry. 2 women and 2 men. This is the one, correct. 2 women and 2 men. So 2 women from 7, 7 choose 2, and then 6 choose 2. So that gives you the second choice. Or means add. Do you see that? Or means add. Add the third choice, and the third choice for you is 3 women and 1 man. So that is your third choice. Find the value, add them up, and you get your answer. Perfect. So that is one strategy. So you could have the cases, and we have three different cases. So we are talking about three cases, right? With and or condition. Do you see that? We have and or condition. So whenever there is and condition, you multiply. Whenever there's or condition, you add, as we are doing here, right? And condition, multiply. So this is product, okay? And the or condition, add. Perfect. Now, strategy two is you could have done the other way. Find all the possible committees and remove the number of committees where there are only women or only men. You get the idea. That is the concept which can be used many times. So now the total number of committee members are equal to what? Find it out. Since there are total 7 plus 6, 13 persons, right? So we have here how many persons? We have 13 persons. So that gives you 7 plus 6, which is 13 persons. And from 13 persons, we have to choose 4. So that is 13 choose 4, correct? So that's what we have, 13 choose 4. And from this, take away where we have only men and or only women in the committee, right? So we have to take them away. So this one is only women, right? All 4 women, no men. Do you see that? So take that away and also take this away where we have only 4 men, right, in the committee. So take that also away and then you get the same answer. So the whole idea is you find total number of committees and exclude those which do not meet the criteria. So those may be lesser number of cases. Do you see that? That could be simpler at times. So that is our strategy number 2 to solve such a question, right? Now here is a practice question for you. I'd like you to read this and then answer. Okay, it says you have selected 5 jazz pieces, 3 blues tunes, and 3 rock songs. In how many ways can you select 3 pieces of soundtracks if you want to include some rock songs? Important. Some rock songs, right? So you have to include at least one. So this is the same way of saying at least one. Do you see that? So we have at least one or some is same thing. So now follow this process. You could use strategy 1 or strategy 2 to answer. Perfect. Now here is my solution to the same. So what we are doing here again is we are again taking 3 cases. Now clearly you have selected 5 jazz pieces. So jazz pieces are 5. So jazz pieces are 5. 3 blues. 3 blues. Okay, let me write like this. And we have three blues and 3 rock, 3 th, and 3 rock music, right? So that is what we have selected. Out of this you want to select how many tracks? So you want to select 5 tracks. In how many ways can you select 3 pieces of soundtracks? You want to select only 3 pieces of soundtracks, so you choose 3. The total is 5 jazz, 3 blues, and 3 rocks. Correct? You want to include some rock. So that means you cannot have a condition where rock is 0, right? So you have to have some rocks. So we'll go for 1 rock track, 2 rock, 3 rocks. That is what you mean, right? Because you're selecting total of 3 only. So those are the 3 cases. You're selecting 1 out of these 3, right? 3 choose 1, or 2 out of these 3 choose 2, or 3 out of 3. All of them, 3 choose 3, correct? Now definitely, when you choose one of the rock, the others will be chosen from the combination of jazz and blues, which is 8, right? So this group is 8. So from 8, you select or choose 2 or 1 or 0 to make them 3 all the time. And then you get the answers, add them up, and write total number of choices. Do you understand the method? So very similar to our approach. Here again we have 3 different cases. Accordingly, list the cases and then do it. And strategy 2 is what, as you must have expected, is something you now figure out what are the total number of cases and take away those which do not include any rock. That means the selection of all 3 has been done from the 8 other pieces, right? So that is a strategy 2. So you could do like that also, which is very beneficial as done here. So total number of combinations minus the combinations with others means no jazz, no rock. So which is no rock means you're selecting all the 3 from jazz and blues, which are 8 in number. Correct? And total number is 11, 8, 5 plus 3 plus 3. So total choices are 11. Choose 3 and from them take away 8, choose 3 to get your answer, which will again be 109 as expected. Perfect. Now here is another very important type of question where we are selecting both or together. You understand? So that's very critical to understand. The question here is, a committee of 5 is chosen from a group of 12 persons when two friends want to be together. Means either both are there in the committee or they both are not there, right? How many different committees can be chosen so that these friends are either out or in the committees? Do you understand? So, many different ways we ask the same question. So, remember, together means both could be in or both could be out. So think like this, right? So definitely we have two different conditions. Both are in or both are out. So we have two different cases once again. Case 1 is both are in, right? So this is both are in, the other one is on out. So if both are in, correct? So we actually have 12 people, right? So 12 could be written as 10 plus 2 because these two want to be together. So they do not be identified as separate. So if you choose two of them to form a committee, then two are selected from two. You got 2C2. You can see that, right? Now remaining three will be selected from this group of 10. So 10 choose 3. That gives you the answer. That is one answer. The other one is they are not there in the committee. So you have a committee without them. Correct? So all 5 are chosen from 10. So 10C5, 10 choose 5 is that group. We get 252 of those. You'll add these two to form the total number of choices. So you have a choice whether you keep them together or you do not keep them. So total will be 120 plus 252, which gives you 372 as the answer. I hope that is clear, right? So with this, we got almost all the concepts of combinations. Perfect. We are going to end with the game of cards. And most of the time, the question on cards is always there in examination. And that's the reason why I have now taken 4 different cases for a very interesting game of cards, right? So the question here is, we'll call this as a test question which you need to answer. The card game euchre uses only nines, tens, jacks, queens, kings, and aces, right? So nines, tens, jacks, queen, kings, and aces, right? 6. And of 4 of each, right? 5 card hands are dealt to the players. How many euchre hands will contain? Conditions are will contain all red cards, 2 kings, at least 2 red cards, at least 3 queens. These are all the different conditions, 4 different conditions which we are going to work on. So first let's try to understand this situation. So we have nines. So we have these nines, tens, jacks, queens, kings, and aces. 4 of each kind, right? There are 4 suits, right? So basically, we have 6 times 4, which is 24 cards. Correct. Out of 24, we have 12 red cards plus 12 black cards. Right. So that is the combination. Now, based on this, and we have a hand of 5, right? So we have to select a hand of 5. Okay. First condition, all red cards we have to select in when we choose 5, all red cards. So what should be the condition? When we choose 5, we need 2 kings in the hand. How many combinations are there for that? Third, at least 2 red cards are there. When we say at least 2, that means either 2, 3, 4 or 5 red cards, right? At least 2. And the last is at least 3 queens should be there. There are 4 queens, so you want 2 cases where you have 3 queens or you have 4 queens. Is that clear to you? Perfect. Now, you need to answer. All red cards, we are selecting 5. How many red cards are there? Total, there are 12 red cards, correct? So from 12, you have to choose 5 all red. You get your answer straightforward. You see that? Choose these 5 cards all red, right? So there are only 12 red cards. We get the answer. Do you see that? Now, 2 kings. How will you answer that? So how many kings are there? There are 4 kings. So from 4 kings, you will select 2. But you have to select 5 cards in all. So how about the other 3? Well, the other 3 will be from, not from kings, right? So from other 20 cards. Since there are 24 in all, you get the idea. So that is how you get the answer for this. And is with multiplication. At least 2 red cards. Now, when we say at least 2 red cards, what you could also do is find total number of combinations and remove the ones where we have no red cards and 1 red card. You understand? So we could do that. So that will give you the answer for at least 2 red cards. So can you help me figure this out? Well, let's find the total. Total will be what? Total combination is going to be from 24 we have to get 5. That is total. Do you see that? From this total we want to take away the cases for 1 red card or no red card. So 1 red card or no red card. So we could take a case. How many red cards are there? 12, right? So 12 choose 0. Well, when you choose 0 of them, so for those from the other 12, you are selecting 5, correct? So that gets multiplied. Right? Plus, you may not choose, you may choose just 1 red card. In that case, 4 will be selected from the other 12. So that becomes the next set, which is to be taken away. And then you get the answer for this. Alternate method we used. But you could also use choices, right? Cases when we have 2 red cards, 3 red cards, and 4, correct? Maximum you can have 4 only. Now, at least 3 queens. So that means either you have 3 queens and there are only 4 queens, right? So you have 3 queens. So in that case, we have to select 5. 2 more will be selected from the cards which are not queens. So that means 20 left, right? Plus, the other condition is you select all the 4 queens and then the remaining 1 will be selected from the 20 cards. So that should be your answer. Perfect. So I hope you understood the whole concept. Here is the solution for you in details with the numbers. So you can actually go through this particular solution and see we got the same result right here with the values. So that is kind of important for understanding, right? So again, in this hand of 5, when we are playing with 24 cards, selecting 5 with different conditions, we need to understand that 12 of these cards are red, 12 are not red, right? Every card, which is like a queen, 4 of that kind is there with us. Knowing that helps us to answer this particular question, and the concept of choose from the given set makes it so simple to work out. I hope you understand and appreciate how beautifully this concept of choosing helps us to count different scenarios and conditions, especially when we are answering questions based on forming teams, forming committees, choosing a group where order is not critical. So remember, you have to use combination when order is not important. I should write bold, right? Not important. Rather like this, not important. Then only use the concept of combination as we did in this particular case. And you can always have the cases of and or, right? So we could have and we can have or, and we could have different cases. Or means you have to add, and means you have to multiply to get your complete choices. I hope with this, the whole concept is absolutely clear. We have many other videos in our playlist in YouTube, so you can always look into my videos, right? Search and then practice from those. Also, practice from your book. If you have any questions, you can always mail me. We'll be there to help you out. Thanks for your time and all the best.